Okay, today we're doing 6.2.2, which is dilations and similar figures. Remember that dilations can be bigger, smaller, or the same. Most people just think of bigger because when you get your eyes dilated, your pupils get bigger, but it can actually be any of those three. Okay, here's the warm-up that you would have done for today. Make sure that you guys follow directions on here. It says to dilate by a scale factor of 2. This is what we did yesterday, which just means to multiply all of your numbers by 2. Go ahead and do this graph on your own, write it down, pause the video, do it on your own, and then when you unpause, we'll do it together. This is 1-20, you guys. It's actually 21. I just switched the two warm-ups because I felt like this was a better one for today. So go ahead and pause and do this on your own. When you unpause, we'll go through the answers together. Okay, so the first thing you should have done is written down your original points. So this one would be -2, -2, 0, -5, -1, 2, 3, 4, 5, 6, -2, -1, 2, 3, 4, -5. So you should have written down those original points, and then it says dilate by a scale factor of 2, so that means we're going to multiply all of those by 2. So here we would have -4, -4, 0, -10, -8, -10, and -12, -4. And you just need to graph those new points now. So we'd have -4, -4. That's 1, 2, 3, 4, 1, 2, 3, 4. So that's a new point. You have 0, -10. You have -8, -10. And you have -12, -4, which is actually going to be out here. So these would be your new points. You guys probably have more graph paper than I did. So it should be a little easier for you to get your points on there. One of mine didn't fit. So this would be your new one. Remember, we multiplied by 2, so this is twice as far away from the middle, and that figure is twice as big. Okay, so we're doing 6.2.2. This is straight from the book, so you can follow along in your book if you like. It says, have you ever wondered how different mirrors work? Most mirrors show you a reflection that looks just like you, but other mirrors, like the mirrors commonly found at carnivals and amusement parks, reflect back a face that is stretched or squished. You may look taller, shorter, wider, or narrower. I actually have a mirror at my house that makes you look really, really skinny. Mr. Moreland loves it. So that would be an example of that. These effects can be created on a computer when you put a picture into a photo program. So when you guys use Word, if you stretch by the sides or by the top or by the bottom, it changes what that picture looks like. It doesn't just make it bigger or smaller. Whereas if you use the corners to stretch it, it's going to make it the same thing, just bigger or smaller. So if you do not follow the mathematical principles of proportionality, when you enlarge or shrink a photo, you may find that the picture is stretched thin or spread out, and not at all like the original. Today you will look at enlarging and reducing shapes using dilations to explore why a shape changes in certain ways. So this is the first problem. It says in lesson 6.2.1 you looked at dilations and multiplied each of the coordinates of a shape to change its size. Now you will explore how to undo dilations. It says Charlie multiplied each of his coordinates of the vertices of a shape by 4 to create the dilated shape at the right. If Charlie multiplied to find the shape what operation would undo his dilation? So we know, so you guys know that addition and subtraction are opposites, multiplication and division. Okay, multiplication and division are opposites. Sorry, you guys, my Apple Pencil died. So if I repeated, that's why. So it says that he multiplied by 4. So to undo that, he would need to divide because it is the opposite of multiplication. I used kind of shorthand there. You guys should probably use a full sentence. So it says on your resource page, you guys don't have your resource page, but this is easy to graph. Don't use the e-tool either. Unless you are on the online book, go ahead and use the e-tool. It says undo the dilation on the graph at the right, label the vertices with Charlie's original shape. How does the shape compare to the dilated shape? So first you should go on here and just label your points. So this is 4, 8, this is 8, 4, this is 4, negative 4, this is negative 4, 4. So if you aren't on the Desmos tool on the ebook, go ahead and pause and graph those before we move on. Okay, so now we need to divide all of those by 4. So this is going to be negative 1, 1, 1, 2, 2, 1, and 1, negative 1. We just need to replot our points down. So negative 1, 1, 1, negative 1, 2, 1, and 1, 2. So it should have gotten really, really tiny. We divided by 4, so as Keenan said this morning, it'd be like 4 times smaller and like 4 times less far away from the center. So it just decreases everything by a factor of 4. So it's going to be 4 times smaller, going to be 4 times closer to the center. This one happens to go through the center, so it just makes those points 4 times closer to the center. So this point is 4 times closer. This point is 4 times closer. This point is 4 times closer, and this point is 4 times closer. That line that went through the center is still through the center. Okay, Elena was working with dilations. She wondered what would happen if I multiplied each coordinate of a shape by 1/3. On the resource page, you guys don't have it. It's just a graph. Use graph paper. The points below to form her shape. I'm actually changing these, you guys. We are going to do negative 3, negative 3, negative 3, 3, 3, 6, and 6, negative 3. Don't graph these points right here. So go ahead and graph those really quickly. Pause the video to graph. When you restart it, we'll go through them together. Okay, so you should have done negative 3, negative, whoa, I graphed that wrong. Negative 3, negative 3, negative 3, 3. I guess that was a point too. 3, 6, and 6, negative 3. This is kind of a funky shape. Okay, now it says we're going to multiply every single coordinate by 1/3. So when we do that, that's the same thing as dividing by 3, you guys. Multiplying by 1/3 is. So just divide all of these by 3. So you should get negative 1, negative 1, negative 1, 1, 1, 2, 2, negative 1. So pause the video. When you unpause it, the points will be up here. You can check your answers with me. Okay, here's negative 1, negative 1, negative 1, 1, 1, 2, 2, negative 1. Okay, we divided by 3, or multiply by 1/3. So this should be 1/3 the size of your other one. I definitely graphed something wrong on here. This is supposed to be at 2. Okay, there we go. So this should be 1/3 the size of the other one. It also should be 3 times as close to the center. For this question, what do you do to each of the coordinates to undo the dilation? You can either multiply by 1/3 or divide by 3. And the shape does not change. Angles don't change. Just the size of the shape changes, right? The last 2 questions, you guys, I want you to do on your own. These are just questions to explore what we learned in class. So you're just exploring, follow the directions. The graph that you guys need is below. So the graph you need is right here. So graph this in your notebook. You're going to use that for these 2 questions. So the first one's going to have you multiply each x and y by 4. So copy down the coordinates of the points on this graph, multiply every one of them by 4. Do your graph in a different color. Then the second one's going to have you go back to those original points and only multiply the x coordinates by 3. This is in your book as well. So make sure you're looking at this in your book if you need to. I'll erase this stuff so that you guys can see it again. But I want you to do this one on your own. You're going to explore what happens and see what happens. And then I want you to answer problem 57. I'm having a hard time with getting kids to watch the videos, you guys. And the videos are like being in class. So that's like your attendance for being at school. So I have to have you guys be accountable for watching the videos. So to get full credit for today for your homework, you have to write your favorite quote on your homework assignment. That's going to tell me that you watched the video if you do that. Your homework tonight is 58, 59, 61, 62, and 63. So make sure you get your homework in, submit it on Schoology, email me if you have questions. We can either do a Zoom or phone call or whatever if you need more help.